Hello everyone, welcome to another stream. How we doing? Yeah, sorry about that. My son needed help getting to sleep, so I was a bit longer than I usually am. So, last stream, what did we get up to? We did some of the tile bidding, that's for sure. Well, I guess in today's stream we're optimizing the tile bidding. I think last stream we generalized it. Yeah, that was it. We generalized the tile binning code for the ellipsoids. So now we've got a nice function, or a couple of functions, um, inside the graphics. It's graphics internal. I'm completely not prepared. In graphics internal, we have tile bin start and tile bin end. We can use these guys to populate some buffers, tile binning buffers, that we and then our objects will be magically binned into screen tiles, and we can then look in those screen tiles and have arrays of objects basically. So it's pretty powerful. So we'll be able to reuse it for the UI system, and I'm hoping we can get to doing that today after we've done some optimization. So I think, yeah, there's like a yeah, so you call tile bin start, pass in a name, you put in your custom dispatch pass, which will actually emit the ellipsoids that you want to bin into screen tiles. So it does like occlusion culling and stuff like that, which we haven't done yet. And then we end it. This will actually bin them into screen tiles. And then here's the ray tracer, which looks over those screen tiles. There's a nice generalized system now. So what we're going to do, so let's give it a run, is there's a shader which takes a long time. And we're going to optimize it for all the different cases where it is going to be slow. So, hey there, Bassandro, how you doing? Welcome, welcome. Hope everyone's having a good week so far. So here's the profiler we've got. We've got some lovely scopes. Oh yeah, was fixing the profiler as well because the times were a bit wrong. But we found all the bugs with it now, which is great. So the times seem correct. So if we get in real close, we don't have any debug visualizations yet, and maybe we'll get time to do that today as well. There is, when you cover the full screen, this ellipsoid gets an access line bounding box around it, and it's going in screen space. It's going to draw. Yeah, it's going to draw an access line bounding box in screen space, which is a rough guess. It's a bit over conservative. And then for each of the 8x8 screen tiles, they're very small. We could probably increase the size, to be honest. We bin an entry. So what happens is there's a few passes to the tile binner. If we just get it to go to the big one, you'll see how slow it gets. Right. So yeah, there's the tile bin ellipsoids, which is 2.8 milliseconds in total. Most of that time is spent in the tile bin splat objects at 1.69 milliseconds. The setup shader is instant. The bin ellipsoids one, which is the one that selects the ellipsoids and emits them into an array somewhere for the ones that you want to bin. Those ones are, again, really quick. We've only got 2 ellipsoids. But then when it comes to actually splatting the objects, so that means basically duplicate the object as many times as there are tiles that it is in. It is extremely slow because it does it all in a single thread of a compute shader, because it's one thread per ellipsoid at the moment, and that works really well when you have very small tiles, like when you're in a very small set of tiles. But when you're in a very large set of tiles, it obviously doesn't handle it well. So we need to write different versions of the splat objects shader. And then afterwards we sort the array. That's about 0.7 milliseconds. We could probably reduce that by simply having less tiles. Because right now that's about 22,000 entries. I could have swore. Right, those times don't add up actually. Maybe we didn't fix the profiler. That is wrong. Huh. Yeah, potentially we're going to look into that because that's throwing our times off. Yeah, we're going to look into this a bit more. I'm okay. 3 days till vacation. Awesome. How you doing? Yeah, I'm not doing bad. Doing quite good actually. Yeah, been quite good. It's my last week of work, so it's pretty chill. There's a lot of people who are actually not in. So yeah, which is good in ways because there's less meetings, but then it's also more difficult because you can't communicate with them about a task. Not too bad. Family's good, thank you. Yeah, the boy's great. Wife's doing good. She's a bit ill though from, yeah, she's feeling a bit ill at the moment. She's got some symptoms for pregnancy, basically. Going through all of that. But it's all for a good cause. Or in the old Coke Zero. Because it's all they had in the shop. No Pepsi Max. Right, so before we optimize that shader, let's take a look at these profile times. I could have swore I fixed the problem. But obviously I didn't. So if we pause it. Right. Take these times and add them up. I saw it was 0.07 seconds. That was criminal. Float. Let's do this thing again. What we're looking at doing is adding all these times up and comparing it to what we are seeing in the terminal. Right, see, so we've got a scope around a bunch of dispatches, and these times should all add up to what is in the outside scope. I don't think they are. So TMS says 0.177, and what we had in there was 0.21. So I think we got a similar problem going on. We definitely improved it though. So what was happening is the time before was impacting the time. So like the barrier, if I could illustrate what the bug was before, and then we can see if it is still that same bug. So what we found out was, so you put your scope in, and then what would happen is this thing would run. No, this thing would, yeah, you would do a dispatch on this. You put your scope in. That says write timestamp in the command buffer. And then you would do this. This would then put a barrier. And then a dispatch. And it's put a barrier for the one before to wait for the one before to finish. The dispatch that ran before to finish. So what would happen is this barrier wait would be included in this sort of like timestamp. You want the timestamp to come after the barrier, and that's what I thought I did. But oh, maybe I did. But shoot. I think I know the problem. We don't want the... It's the way the pipeline stage arguments are passed into that right timestamp thing, I think. So let's put our... where's that sort? We can see how it works. Right, here we go. So if we put a breakpoint there, we'll be able to see exactly what goes on. And how it gets recorded into the command buffer in what order. So we do our splat objects. This is the slow shader, which we'll optimize very soon. So when we dispatch this command here, it's going to put a barrier in. Here in the prepare, there's a emit barrier basically. Right, and then it puts the scopes. Yes, the scopes that go in are sort indirect. Right, perfect. That goes in the right place, I think. Because then right away after it does the dispatch. So the barrier went first. Then what followed was the yeah, cool. Right. So I think my thinking is with what is wrong is we are it's hard to get this stuff right because the documentation in Vulkan isn't really the best. It's like really wordy and it's difficult to understand what it exactly means because it all references other things which are in different sides of the document and all very specific, complicated language. So effectively, when we write those timestamps, so in prepare, do this command. So we had to defer them so they could happen after the barrier placement. I think this here needs to be the compute stage. So what this is saying is when the command is read from, so write this timestamp when the command processor reads this sort of packet from the command buffer but hasn't executed it yet. We need to put a stage in it, like a proper stage and not a sort of pseudo stage, right? Like a fake stage, like top of pipe. We need to put probably compute shader in, and that will then mean that when the compute shader executes, perhaps then write it. We can try and look at the docs again. It's just complicated. Hey there, Perry. How are you, sir? Are you a big fan of Perry? Or Perry, however you're going to pronounce it. It's a stage. Specifies the stage of the pipeline, right? And then you say stage. First synchronization scope includes all commands that occur earlier in the submission order. The synchronization scope is limited to operations on the pipeline stage specified by. Implementations may write timestamp that is logically later than stage. Any timestamp that happens after in the same submission must not have a lower value unless the value overflows. Blah 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 blah. Right. I don't know. It says it's difficult to tell. The second synchronization scope. Try and re-understand this again. So is it before all the there's all the commands that occurred earlier in the submission order? The synchronization scope is limited to the operations on the pipeline stage specified by stage. Right. Still don't fully grasp it. Fine, doing some advent the code and having fun. Awesome. Good stuff. Piece of crap. Probably might finally load. Probably in this section here. Alright, I think it's this sort of stuff. Synchronization scopes define which other operations a synchronized command is able to create execution dependencies with. Right, let's just try it out and see what happens. On Linux, yeah, so what happened is I tried to get it working. I did get most of the way there, but so my game didn't work on Wayland through X Wayland, so I had to switch over to X11. But also OBS didn't have the web browser extension, so I can get the Twitch chat up, which is very beneficial for people so they can go full screen and still see the chat. So yeah, Arch Linux doesn't come built in with OBS browser for some reason, though, even though it's built into the browser these days, or sorry, built into the OBS repo on GitHub. I don't understand why fully, but they have it in the AUR, but it involves like installing a bunch of other AUR packages which change default selections of things, and it was a pain to build. So I just resulted in getting the flat pack in the past. So I think I'm gonna get the flat pack again. Yeah. So I got to get that thing. I'm not a big fan of these flat pack things, but they do fix problems with Linux where everything is installed with a system package manager. Um, yeah, you know. So yeah, and also trying to fish data out of a flat pack is just. I was trying to do it earlier with trying to get my previous configuration out of the flat pack, my previous install of OBS. It's buried in these weird directories. It's a nightmare. But yeah, I'll hopefully get some time at the weekend to get it actually working. The pain in the butt. Yeah, these times are still actually wrong. Horrendous. When does the final timestamp end? Is it the other way around? No, it's specifically tailored to this, isn't it? So there's a barrier that goes in. Maybe we need to do bottom of pipe, top of pipe. That pack should be banned. Yeah, I do agree. I do not like them, but they do fix this one particular problem. Like, I think there is a problem on Linux. I do not think. Yeah, I do think there's a problem with the way that Linux does, that package managers, they just suck. They're not a good solution for shipping software. But I do not think, but I think Flatpaks and Snap packages are worse. They just don't work with the Unix ecosystem well. You just train a bunch of crap on your system in different places, and yeah, it's just not really good, is it? Plus, like, themes don't work sometimes because they're too busy trying to get that all working. It's just absolute nightmare. Right, the times are messed up. If I put it both compute, does that? Hello, I'm a newbie to C++. Could you please tell me how you do your free objects when you're not used anymore? ACOCON. Yeah. So basically, what I would recommend is if you're a newbie to C++, you become a newbie to C. So with problem with C++ is it's just too complicated and over the top. It'll teach you a lot of bad habits. If you program in C, you will just be you have a much simpler language to learn and understand. You'll pick it up a lot easier. You won't have to try and learn these sort of abstractions that are built on top of C and fundamentally make things worse most of the time. And you can learn a sort of less dogmatic approach to programming. Answering your actual question, memory allocators. There's a Ginger Bill custom memory allocator blog. It's really good. I recommend to people this all the time. So start for part one. It's the main one. Part two is the first sort of two are probably all you need to sort of read and really understand. But the rest of them are additional things which will help expand your like these are more rare cases where you don't really actually need these ones. But they are pool allocators probably yeah, the main two are the ones you really want to read and understand. They really sort of change the way you think. So essentially, you need to think about grouping. You don't free individual objects like a destructor in C++ will want you to do it. Right? Destructors like you're freeing a single object. What you want to do typically is you just allocate a bunch of objects like you don't care. And at some point later on you're at you basically say, right, all those allocations that I did in the past, I can just wipe them all in one go, and it's as simple as changing one integer. So it might sound quite crazy, but if you read through those, you'll understand, and that'll mean that you that sort of malloc and free sort of pattern that you see all the time, which might be quite hard to keep track of and stuff like that, or new and delete. Um, all of that basically just goes away, and you just allocate a whole ton of places, and you just do a free in a single place, and it's fast performance, simplifies your program and the way you think about the memory as well. I had to think about it all in lifetimes. So, um, yeah, those are the two things I highly recommend. Um, but yeah, really helps programming in C, and you don't need all this sort of like destruct language stuff. Not really needed. If any C just had defer, yeah, like you kind of get around with it with the go-to. I think when people say like go-tos are dangerous, the only time I see that go-tos are um like the only practical use I see of a go-to is to basically implement defer. And then if you had defer, I could then probably agree with the statement never use go-to because it's dangerous. Um but yeah, you do have go-to to implement defer at least. Um but yeah, it would be nice, wouldn't it, to have a proper go-to? Sorry, defer. Yeah. Oh, switch. Yeah, all we needed is switch. Yeah, it comes built in. Yeah, I can't understand why these timestamps are wrong. Still wrong. It's just insane. The It seems to be including the time from before. It's just um, there's no real good example codes for these. Right, see if this tutorial helps out. If I don't get, I have to decipher all this damn C++. Uh, yeah, top of pipe, bottom of pipe. That's what I'm doing. So let's see if I can understand. Right, so I'm getting time and information on CPU. You start time and information that can be queried immediately with GPU timestamps. We need to tell the implementation inside a compute buffer when and where to write the timestamps instead. The results are fetched as we'll see below. This is done inside the command buffer, the right timestamp function. This function will request a timestamp to be written from the GPU for a certain pipeline stage and write that value in memory. Probably just a buffer, right? That could have just been a Vulkan buffer, but no. We need another type of object. The most interesting part of this calling this function is the pipeline stage argument. As noted earlier, it's technically possible to use any pipeline stage in there. Not all pipeline stages yield proper results due to how GPU overlap work. It's important to note that not all implementations are able to latch timers at all pipeline stages. E.g., if they don't have hardware that maps to that given stage, the return timers at a later stage instead. Calling this function also defines an execution dependency, similar to a barrier on all commands that were submitted before it. Interesting, I didn't rock that before. So putting timestamps in puts in barriers basically. Right. Huh. To measure GPU times for all draws, you must first tell the GPU to write the timestamp at the top of stage. It's not really a real stage, but special constants tell the GPU to write timestamp when all previous commands have been processed. Well, it doesn't seem like that is happening when I do this. Because as I get closer, well, maybe. Oh, maybe there's another problem that's happening then. Right, so apparently what this code write, just put it back. People getting offended by seeing go-tos is funny to me. Yeah, but there's a few cases where in code where a go-to does make it so you can do where the logic, structured expression logic, like if statements and while loops or whatever else statements. Go-tos allow you to do things which are physically not possible with those things. But off but 99.99% of the times you just need to refactor your code such that it does work without the go-to. But yeah, there are other cases where the go-to is probably needed for certain reasons which are not possible. But I don't think I've ever needed one. Maybe for optimization purposes, you could probably argue. What you really need is a go-to with a by dereferencing a variable. There's an extension for it. That's a more useful one. In which clauses essentially go-to labels. Yep. I'm catching up with some new plus 23 event code past couple of weeks. Then they had a lot of nifty stuff there. Nifty stuff to C23 or plus C plus 23. What sort of stuff? So I guess let's look at my query results thing. There's a result wait bit thing. But I don't really do a wait. Tells the API to wait for all results to be available. When using this flag, the results written to your timestamps vector is guaranteed to be. Wait. Hang on a minute. Are we reading half done results? Using this flag, the values written to our timestamps vector is guaranteed to be available after calling this. This is fine for the use case where you want immediate access to. Interesting. So what could just be wrong is I'm getting half filled in data. Maybe. Alternatively, you can use result with availability flag, which will let you poll the availability of the results and defer writing new timestamps until results are available. This should be a preferred way of fetching results in the real world when using. I don't really care so much, but so you would. Right. Right, you just keep checking. Yeah, I don't care, still. Well, um, let's see if that fixes the problem. So it's interesting, the guide that they have actually reads like English, whereas the spec is just. Come on. Right. So it's not letting me press escape and kill the right, there we go. What's happening there? Something's messed up. Right, I think that's better. Because it was getting to 0.7 milliseconds, and I cannot press the escape key and get it to grab the mouse. There we go. So it locks it in place, stops moving the camera, and I press escape. Yeah, so let's get right in there, make it a big old, so it covers up everything. Those times. It was getting to 0.7 milliseconds when it was full. Right. That sort indirect is now about 0.2. Maybe that's helped fix it. So I grab all of those. I don't think that adds up to 0.2 though. We can quickly test it. That finishes then this one. Yeah, I gotta pause it. Cool. Right, let's take all these. We'll compare the times. So I struggle to believe that is 0.21 milliseconds. Looks maybe to be less. Right, let's try that again. Let's just debug all these lovely times. So this has to be 0.2 1 millisecond, something like that. No. Right, pretty close. I would like to say this up. That is acceptable margin of error. If I add them all up individually, what's 0.19? So it's about 0.02 margin of error. That includes stalling for stuff to be maybe finished and writing some timestamps out, stuff like this. I think that's acceptable margin of error. So, right, I think we corrected those times now. I think. Right. So where was we? Now we've got correct performance times. The problem was in that now that we've generalized the tile binning side of things, we first start off by just setting up the environment with this sort of this one in it. Yep, so we just sort of clear a couple of globals. After the tile bin setup start function, the person who's called this tile bin start puts in their own shader, which will effectively increment this tile bin objects count by finding all the objects they want to bin and emitting it into some array called tile bin objects buffer. Right? And then after that, we call tile bin end. And then there's a splat section, which will, if we look at the splat objects, this is going to go per thread, one thread per object you're trying to splat. So the idea is you want to duplicate the object you're trying to bin as many times as it does overlap screen tiles of currently 8x8 screen tile size. It is, you can change it depending on the thing you're trying to bin. I think we do want to make it bigger, especially for 4K screens. But currently one thread is going over every single tile. So this is a 2D loop, and it's very slow when you have a full screen pass. When you have just a little 2x2 or a 1x1, probably okay. This is like an O of X and Y complexity. It's quite well, I guess you say M&M, isn't it? But it's quite bad. Yeah, so we're duplicating the object that many times, but changing the sort key such that tile index is in the high bits and the depth is in the low bits. So it's got a slightly different tile index to the other ones. And then after we've done the splat objects, we do a sort them all into place. So that means they're all sorted by tile, then by depth. So there's all these different sized arrays within a single array. Then we basically find the start and end points in this shader, where it just goes over every entry and sees where things start and end. Yeah, and that's the generalized tile binning algorithm. So let's make this fast. How are we going to make it fast? Well, how you make it fast is that you build different versions for each type of each number of objects that you have. So I think, right, we want to say if you have just one if you have just one, it's probably got a specific shader. Two, having one going to be kind of rare, but let's see. Maybe we'll do powers of two to see. Well, it's quite easy to see. So your problem is you're going to have 10 different shaders if you go all the way up to 1024. So you could have 8 different shaders if you go up to 256. And if you have 256 or more, then you just use the same shader. Yeah, I think we'll do that. So maybe we'll have, for each power of 2, we'll have that's 8 shaders. We just got to figure out how we're going to do this. We'll have maybe different arrays where these objects are stored in somehow. And then we can dynamically dispatch all these different splat object shaders, which are optimized for. See, that's the thing. I think we can do powers of 4. So 1, 4, 16, 64, and what's the other? It's 256, isn't it? Be pretty legit. Then that'll be only 5. So we did powers of 4. That would still fit into powers of 2 things. So you could probably do, there's still powers of 2, so you could do some bit tricks to help figure out how to bin objects into what array. You have less arrays and where the objects go. And the shaders should be optimized enough for those specific workloads. Yeah. I don't know if we need a 1 because the 1 could just be like the 4 right? Um, so if you have a 2 by 2 set of, because typically, right, if say if you have a tile which is an 8 by 8 set of pixels, and you're trying to build an array of objects for that specific tile, right? Well, typically, if your object that you're trying to draw is less than like 8 pixels, right, it's very rarely going to fit into a single tile anyway. It'll be very rare, right? So it's probably going to overlap with at least one border, so you might as well have it work for two. But then it could quite easily overlap 4 of them if it's in the right place. So I don't think, we're probably not going to get a lot of one side, very small objects like this in the game. And we're probably not going to get, that'll be a quarter of the wave occupancy, while the other threads. So I think it'll still be in this kind of for loop, right? And we'll just get the same sort of, you have 25%. Is it wave occupancy, I think? I forget what it's called. Yeah, it's wave occupancy. Where you'll have a bunch of inactive lanes, so it'd be 25% on some cases. Which I think may be okay. We'll see. But let's just say there's going to be 4 of them. That means there's 4 arrays. Can a compute-based render be faster than a traditional pipeline? So I think there's cases where it can be. When you're trying to do stuff that the traditional compute pipeline is not built for, like it's built for rasterizing a bunch of triangles of reasonable size, right? Whereas if you have a bunch of like small triangles, that's not what it's built for, because you've got a primitive in compute shaders. Well, and pixel shaders, right? Because basically pixel shaders are just used to compute shaders or the compute units under the hood. You got a quad intrinsic, right? So there's always, within a quad, it's guaranteed that each thread, like at minimum, they need a quad that runs on a single triangle, even if the triangle doesn't actually overlap all these pixels. The MIP, to calculate the derivative when it comes to doing sampling, so you can calculate the right MIP level, right? So when you have a bunch of small triangles so this example here is 75% effective, because this lane here in the compute shader or in the pixel shader that's running will not be active. It'll be active, it'll be a helper lane, but it won't actually compute any final pixel color. So if you have a tiny triangle like this, you're getting 25% occupancy of a quad. So you're not actually going to get. So this really impacts performance. So what Nanite did is they wrote a very small, tiny triangle rasterizer. I think it wrote to the visibility buffer. I'm not sure. There's a bunch of resources online. Nanite tech blog or something like that. Deep dive Nanite. But yeah, if you find there's some blogs online or something about how nano works. And they have a little triangle rasterizer in software for all those tiny triangles. So they figure out which triangles are tiny and put them into a separate compute pass and rasterize it. Yeah, that's what they mean in software. So it's ran on GPU hardware, but it's a software rasterizer, right? So that's what you can call compute based rendering is software renderer. Yeah, it's still a software renderer. So, so that means that the shader that the user makes has to figure out which one of these it goes in, and these arrays have to be big enough to hold everything. So I think I got myself an idea. We can max allocate these. It wouldn't be so bad because I think the maximum number of objects we can bin is 64k, which ought to be good enough for anybody. Famous last words. Then tile bin something. I feel like I picked 64k just so I can say that. Just all the time, 64k everything. Good number. So we should probably have, there's actually a bunch of object buffer IDs, and you want to have like this is a good song. So where I have that tile bin stuff, we will just say define graphics tile bin object buffers count 4, right? 1 for each power of 4, starting from 4. No, I won't bother. We'll do that in a bit. So, or maybe I can say we have 1 buffer for each power of 4, starting from 4. Maybe we could do it from 1. I don't know, I'm thinking about that nanite thing I just went over with 25%. But I don't think we have a lot of tiny ellipsoids, right? Maybe. Hey, Type Beaver. How you doing? Oh my gosh. Coffee lava. It's another Twitch streamer. Welcome, welcome. What sort of projects you've been working on lately, Coffee Lover? Your lovers? Are you lava lovers, coffee lovers, or lovers lovers? Or all three? Or two? 3. We have 1 buffer for each power of 4, starting from 4. So buffer from object count. See, this is where we should say bins, object bins. bins count, bin from object count, point. So this is where the magic happens. So what you typically do is you get the you only get the most significant bit, right? So if you have dun, 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 dun. Right, if you have like let's say you have the 416 sorry, 416. Right, let's just say you have 17. So yeah, 16 sets that bit on. So you do that most significant bit, you get the index of 0, 1, 2, 3, 4. Right? And so with 4, you'll be able to divide by 2 because we're in powers of 4 instead of powers of gotta be careful though. What happens if you got 8? Divided that by 2. And that'd be the same as no, when obviously I get 8. Right. Yeah, so that'd be okay, because they're think. Or do you want to divide it by 4? No. So 4 divided by 4 obviously get you 1. That's great and everything. Yeah. Right, powers of 4 might not work the way I was hoping it to. So what we're trying to do is say, so given you've got 1, 4, 16, 64, 256, we're going to get rid of the 1. So the basic idea is to convert, when you come across one of these numbers, into an index, so this won't be 0 actually, this will be rounded up to 1. But yeah, this would be what? Oh yeah, they'll both be 0. Sorry, this would be 1. This will be 2. Be 3. So we're trying to make the maths that does this. So if you do 4 divided by 4, you obviously just get 1. You could take 1 and get 0. If it's 16 divided by 4, you're gonna get 4. Which is obviously not gonna be anywhere near what you want. The 4 is there. Gets you 1. So it shifts right by 2 basically, isn't it? So what we did is we did the I guess maybe you call this function twice. Bit, most significant bit. I think maybe you call that twice if you want to get a power of 2, the power of 4 index. So we did this, you'll go 0, 1, 2, 3, 4. So you put that gives you 4, right? And then do it again, 0, 1, 2. And that'll give you 2. Then you take 1 and you get to the one that you want. Yeah, perfect. Yeah. So I think you just got to call this twice. Since you want to get, and then you do a take 1. Because that's, is the power, sorry, 4 to the power of 0 is 1. 4 to the power of 1 is, 4 to the power of 1 is 1. 16 to the, oh, sorry, what am I saying? Yeah, yeah, 4 to the power of 1 is 1. 4 to the power of 2 is 16. 4 to the power of 3 is 64, right? Yeah. Yeah, 4 to the power of 4 is 256. So, but then what we want to do is be able to take 1 because we're essentially starting off at 1. Sorry, we're starting off at 4, isn't it? Yeah. So then these will just all go like that. Neat. Oh, that'd be good. So now select the right bucket. So now we have to do is get all the buckets. So you're in the bin objects. So these are the object tile bin object bins. Bin object, okay. Object bins. There's 4 of them at the moment. Hopefully don't have any more. And yeah, so we'll set all those. They're different buffers, obviously. Maybe though, they could just be a single buffer and you just have an offset into it. Having different buffers is just a bit silly, to be honest. Yeah, so maybe you could work out. The issue is you need to be able to. Alright, got ideas. Yeah, maybe we should have. Yeah. You get the bin, you can atomic add to an integer. That integer will give you an index to write into. the entries into, and then I guess you need the log4 base of x. Yeah, that's what I've hopefully done with this. I think it worked. I can just double check it again. So I took 256. I did get the most significant bit index, so that'd be for 8. So 8, so you put 8 in. Then you do it again. That'd be 4. And then did it take 1? And that did it. Got me 3. So it's a pretty good way of doing it. The take 1 is only there because I actually needed to take 1. This is off by 1 of log 4. But yeah, that's correct. Seems like it's right. Hey there, Underdog. Welcome, sir. Right, I'm just going to quickly take a little break, get another drink, and then we'll... Right, welcome back everybody. So yeah, I think we're probably better off with like a single buffer object. So we'll do that. Object. Did I call them bin objects before? Alright, bin objects. So we need a way to get a bin offset. So the bin offset, we're passing the bin index. What's the total number of objects in a bin? Oh, yeah, done that. Here it is. Where's this boy? Alright, so you're up there. Okay, well, I need you down here. Don't do this. Good. Okay, so that's how we get an offset to the bin at least. Find the right array. There's still just one array. So those bin objects, this also needs to be multiplied by the number of bins. Nice. I was thinking, where can we store these atomic counters instead? I think we're going to have to put them in the in that global buffer still. There'd be 4 separate counts. Yeah. Yeah, I don't remember getting a line of working. I'm thinking we might want to space them out a bit. They're not in the same cache line. Avoid that false sharing thing. I don't think I added it to my compiler. Let's have a look. Go into HCC and have a look. So I think it AST gen, let's look at that one. Align as. Interesting. I process it at least. Where's this in? The compound literal, you can do it. But why? Did I really support that? Hannah, did I get that to work? So it rounds up the size. No, it doesn't. Here you go. Line as is, oh, Bitfield line as not supported. Right, good, good, good. Store here layers. We need to calculate the proper offset of the fields. There's a byte offset on the field apparently. I wonder. Yeah, and then it computes the overall alignment. So the question is, in reduced PV generation, do we use the byte offset at all? Oh. We do. Oh yeah, past Henry. Doing a good job. What a guy. So we should, if this will work. So I think we want to take those bin objects and basically stick a bunch of padding in between them. You might have to wrap them in a structure though. Yeah, I don't know how a line has with an array should work. Yeah, we ideally want like an array of these. Like that. Let's see if it works, if interesting. Well, it's like a Do you have to really wrap it in a structure? We'll find out. Align as. Oh wait, isn't align as? Is it not taking a number as well? Yeah, you get the expression, right? Did I add support for that? I think I only did a type, right? I wanted to do cache line. Just to write 64 in there. If that works. See if it compiles. Alright, so straight away my compiler complains. What does it say? It's type name. Right, okay, I don't support it. I've got the code in there though. Yeah, I do remember writing it, but I don't remember I tested it. Oh no, align as goes on the stride itself, but you can... I thought you could do it on a field. Okay, maybe not. Right here instead. Incomplete type. Where do I process it in the compiler? I closed the damn Visual Studio thing, didn't I? Align as token. Process the specifiers. Yeah, I do it as a field argument. I didn't. Did I do it in the wrong place? I swear you could align fields. Yeah, you can align. Oh, you can align variable declarations, but not fields. Maybe. Right. Oh, you can do fields, but maybe not in C++. So I wasn't really seeing it. Right. So I think the reason why that didn't show up is because it needs to be the C way where it's like align as that, basically. I don't have the macro for it. There you go. That works. Let's see if that works. Good old C11. Hey, Robo. Hello. Still no major reinstall I see. Mind us by now. Yeah, I got Arch installed on another drive now. I just had trouble with OBS and package managers and things to get certain things installed properly, like the OBS browser plugin. So we can have the Twitch chat still up on the side, so people can watch the stream full screen and not have to have the chat open the side, you know. So that was a bit. That was. I've got to install a Flatpak. So I'm going through that process now and still setting things up. But I think the next time I'm going to get time realistically is Saturday. So maybe by Sunday we'll be back on Linux. Cool. I think this is not in. Not my core shared, that is for sure. Let's see if it works. Line to cache line to avoid false sharing. Too much. Or to reduce false sharing. So that means different compute units, when they access this, when they atomically add the same variable, they'll be doing it less because there's 4 of them. And depending on the compute shader which is running, the type of compute shader which is running, it'll do a different one. So that's the hope. There's at least some spacing between them there. Cool. Oh yeah, this wasn't declared in the right place, was it? So we actually need to take all these silly old constants and put them further up. Unless we move the global's definition lower. So this could then go in the tile section, which would just be amazing. Like, yeah, I could have stuck it here, but I didn't know what it would do on an array type. I might have got that wrong in my compiler. I have no idea if it aligns the element or the array as a whole. That up to, I don't know what goes on. So this would be the globals. The share between CPU and GPU. Well, some upload from CPU, whereas some are just purely managed on the GPU. But they're accessible from any shader. Cool, does that still compile? Alright, let's have a look at some of these other errors. Yeah. Right, if we was to simply just put this back in, it's because I want to get stuff working. I just want to see if that align still works. And if it's not gonna... $10.27. Right, there's me just being a melon. Alright, so hopefully it still produces a valid SPIV binary. I think it did. What's this? What's it doing? I think it sometimes does this because the console window or something causes the application. Again. I'm hoping that's not reading an invalid SPIV binary and failing. Yes, it works. Well, at least it's a valid SPIV binary. I don't know if the align as actually works. I don't think I've tested it yet. So, this is where we get to test it all out. So, what are you doing? Do not do that to me. Visual Studio sometimes likes to open up different files with the same file with a slightly different path. Path just being one with backslashes instead of forward slashes or something like that. I don't know what I've done to deserve this basically, but it does it sometimes to me. I want to get back on Linux. Oh yeah. Okay. So, hey Lupo. How's it going? Yeah, not doing bad. Not doing bad. Pretty good actually. Just yeah, been very very busy. Normal. Um, but yeah, things are going good. How about you? Last week at work for me. Then I'll be off for 2 whole weeks. Christmas. Managed to book some extra holidays. So I'm looking forward to that time off. Gonna spend it with my boy, hopefully get him walking. Right, so we've got this big old buffer now. It's multiplied by the number of bins. This is where the fun begins. So we get the bins, or the yeah. So I think the idea is we want to go to the one where we actually tile bin ellipsoids. It's called. Probably going to change the name, but it takes all the ellipsoids that have been uploaded from the CPU, which is obviously going to change later on when we add model instances. Figures out their screen space, bounding box, and then emits this thing called a tile bin object or some tile bin object. It sets the tile range and the depth and the object itself. So it's just an ellipsoid index in this case. There's 12 bytes. Unfortunately, I can't make it any less. It might be better off to pad it. I don't know. Then things would be cache line aligned, maybe. Yeah, this consider that. So to do test if this helps with performance. As it will ensure that all entries, that a single entry lives in exactly one cache line. I don't know. We'll see. Maybe it won't. Future Henry can figure that one out. Good old Future Henry. So maybe I need to write out the full cache line as well, because there's issues where if you don't write out a full cache line, it will have to read back the memory from RAM just so it could fill it in again. Sorry, just so it could write back a whole cache line. Yeah, stuff like that. Careful of. So right, so this is where the magic happens. We'll be able to. So that atomic index is no longer this one here. Let me delete that. Good. we've got to figure out how do we. So we've got this object counts with an S now, right? Or plurals. So we need to calculate our bin index. So we need to use this, get our bin index from bin index. Bin index. Or maybe I don't need it. So how many objects we got? Wave objects count. Neat. So you would index this with the address to the atomic add. Nice. Target your base insert index, share it with the others. So I'm thinking we should initialize these object counts with, to make the user code a bit easier. I think what we could do is do a for loop over all the bins. And initialize it with an offset. So they will be so we don't have to do that addition per object that we try and insert into these arrays. And instead we do it per group of objects when we do the splatting. Maybe. We'll see. It makes the user code easier as well, so the complicated bit is in the offsetting code is in the generalized function, which the user doesn't care about. It's very it hides a little bit from them, which is interesting. So all they have to do is get the base insert index, and then just use that and insert their object. Be nice. So I think that's the adjustments we need to make, right? So we should get less false sharing here. You'd only get. Wait a minute. Oh. Wait a minute. We're trying to bin. Shoot. So you're getting a thread for every single ellipsoid. We should be. It might go into different bins. Crap. Maybe this won't work. So it's actually the number of tiles. I don't work it out here actually, thinking about it. We need to do a subtraction or whatever it is. In that general code, our bin code. Go do the splat. That code. Right, so maybe actually, okay, this is problematic now. Because this was doing a nice little optimization where it was taking all the threads within a wave and doing one atomic add operation. But now, each of these ellipsoids, yeah, you might have to use you can still do the same thing. You just do it for the first four. Yeah, you can do it for the whole thread group instead, or dispatch group. So we'll use right. So we'll make some kind of structure. Oh, this isn't very nice. We should probably make a shared function now which actually does this. So we need a way to take um to take in every tile count. I guess let's write it out here quick. So let's call it graphics tile bin emit LDS, something like this. And I think we ultimately just want to store four values in here. So object counts, one for each bin. That should change from tile. So there was a perfect. So I think we're going to make some kind of function. So tile bin emit. So the function will essentially figure out which bin you go into based on the number of tiles this ellipsoid overlaps, and then atomically add to this LDS memory. And since it's in LDS memory, the atomic add will be a lot more efficient since it's just it's AMD RDNA compute unit. It will be where you at? Where's the image? essentially there's only, it might be shared with another compute unit basically, but it's closer than, it's L1 cache rather than like L2 basically. And it's probably only shared with another compute unit which runs at the same time. So it shouldn't be as bad as atomically adding out to a buffer. There's a document somewhere where we can see a proper picture, but I don't think I can find it quickly. Nice, have a good holidays. Yeah, exactly. That's our break. Any SIMD coding on the horizon? No way. SIMD is only like when I want to do optimizations, and that's going to be very long time away. Feature Henry V. Oh yeah, Feature Henry. Yeah. Um, who's Henry the Fourth? Is that me? RDNA 4 is coming out now. Yeah, I think it's I think I saw it in the news recently. It's definitely coming out soon. I think it's predicted for like start of the year, and I think they've already unveiled some stuff about it. I remember seeing some things. Yeah, I'm not terribly fussed about them. I just maybe you could do some stuff to make that better. You could probably say which ones are the waves. I think you can do like a ballot or something, and the ballot will wave active. Is there a ballot? I haven't even got ballot. I think you could do something like figure out which threads have the same one as you. I think that's a ballot. I don't think I've got it in mine. And you could say like, well, the lowest thread index that has the same as me, that's the one that no, that's just a right. A ballot is you cannot do that. No, right. Ignore me there. All right, let's just try that out. So you add it to that sort of local LDS one. Then you probably need to do like some kind of barrier. I think it's called like a control barrier. We want it to actually block. So they're called control barrier dispatch group. So what this does is it's going to got 256 threads running. So a wave is 32 threads, right? It's one SIMD unit. When a wave reaches here, it's going to wait for all other waves to get to this point. They all run at different times. You know, they only run one at a time, and it pauses and runs the next one. And this will be shared. This will be in the L1 cache or something like this. So after this point, all of the waves would have And all the threads within a wave will have added into this. I wonder if we can make that better. We'll see. Let's just get it working. Then after you've done this, you can take the object. You can get the first 4 lanes. I think you do another barrier. Means generate some insert indices. So we'll call this our relative insert index. These all need to be initialized to 0 as well, damn it. If SV dispatch group local index is less than 4, or not even 4, less than this bins count, you've got to initialize them as 0. SV dispatch local. This would be a value from 0 to 255 inclusively. So we say if it's less than 4, because it's the local index. Cool. And pause execution. Right, relative insert index. Control barrier dispatch group. Now this is where we get to pick 4 threads, which will each get to do their own atomic adds. I think you just take this code here. They will just so I think it should be as easy doing that. But for the insert indices, yep, we'll then add. I guess I'll put this in a local variable here. These are the object counts. Bin object count. So we'll essentially do an atomic add onto the global one with this. Cool. Then that will populate nearly there. So we get the base index for the given bin. Be this one. We should already call them base insert indices. A bit better that way. Is the base insert indices for a given bin plus the relative insert index like so. And then voila, you have yourself your super lovely insert index, and you can insert into the array. Oh, so that should hopefully be the more optimized approach. You're doing this add less into main memory, so there's less synchronization across compute units. That is the hope. All right, let's just double check that all still works. Makes sense. So, right, we've got this sort of LDS memory, so that is memory that is specifically for 256 threads only within a thread group, right? So when you launch the compute, yeah, so the object counts for the amount that we want to add to the global variable, and then after we've got the result afterwards of where that sort of base insert index into the big old single bin objects array is in main memory. So we get the first 4 threads because this is 4. And we say just initialize the counts to 0 because we want to atomically add to these. We put a barrier down so it synchronizes with the other waves and also halts. All the waves at least get to this point here before it carries on. Then it says if you go out of bounds the number of objects, then return. Cool. Right, so a bit of a problem there. We do a return, which means that you're not really the first 4 at this point, which kind of sucks. Oh, no. You will, because that's linear. Yeah, but you've got to have at least 4. You could have 2 objects and you'll never get 4 of them. So, which we have right now. That's the thing we do right now. We have 2 objects only on the screen. So, if you want this to work, this discard actually needs to happen later, but then the problem is you do a bunch of reading here and it sucks. So how are you going to achieve that? But you don't want to do any additional loads as well. It could kind of be that got me an idea. Wave prefix sum. Oh yeah. Right, so you just do a prefix sum. Right, wave prefix sum E32 of 1. Right, all the active threads within a wave will add 1 and it progressively returns you a result. So say if you have 32 threads in a wave and all of them are active, it will each thread within the wave will go from, it'll start at 0 and go 1 2 3 4 5 6 7 8. So rather than returning you the sum of everything, it returns you the sum up to that certain index within the wave. So we can use that to know which are the first 4 that are active. But then if they're not all active, it's a bit problematic still. So you could also just do a for loop on a single thread. That will kind of suck though. Crap. Yeah, sorry, this solves the whole problem, doesn't it? Well, yeah, if you did wave active sum, you can then basically do a for loop. Bins count, right? And then you'd have to say, so you skip by that, step by that. And now you get your sort of like actual bin index, if you will. So this would be the target bin index, the index plus wave active prefix sum. It's a bit dodgy, to be honest. Hopefully it doesn't impact performance that bad. That'll be like, they'll all be active, right? Yeah, then if the target bin index is less than that, then actually do your thing. Right. I just fixed the bug there as well. Cool. So, ooh. This is one too much. Let's try Nick Johnson. So, right, let's read that again. To get the number of active threads that are here, sweet. Go loop here until we've satisfied all that. It should only loop once, but we might not. So you do this base index plus the I should call it base maybe. Base bin. So all the active ones which fit into there. Yeah. Right, then add the prefix sum, the first so many, and then it's still less than the count. Right. Get the object counts, and then do the atomic, do the atomic add. This thing, the result is the base insert index. Great. Control barrier. Base insert indices, and then you can do your thing. So I think this could be a function call. This whole thing could be a function call. Maybe including this as well. And it will just return an insert index for you. So that would be pretty awesome if this could be a function call. Yeah. So we'll look into that. We might have to start the function call as well with a bit of code that does this part where it zeroes it. There might be a bit of a pain, but it's still possible. Might have to do this silly sort of loop thing again. Yeah. But let's just get it working and we'll put it in a function in a minute and make it shareable between the other ones. So, right. So let's get the rest of the shaders. So this is this side done. Now we've got to create the different splat shaders. App always open. What are you? The old one, okay, it's fine. Right, so different splat shaders, splat objects. So let's create the 4 that we need. They're just gonna be the. Right. I guess let's get one. Yeah, let's write one of them out. We'll copy paste it 4 times, and then we'll. Test it all out. So we need different launch arcs. So splat object setup. We would like to say for each bin basically. So you would go over all of the bin index equal to sv dispatch local index, right? So you retrieve from the globals the number of objects in a bin. And then divide round up this and store it in the dispatch args for that bin. So that means each of these indirect args have got an indirect buffer. We're going to have one for each bin. Well, let's get that right. Cool. Right, that sets up the splat ones. Okay. So what the splat one is going to do is it knows which bin index it is. So it should be able to hard code that maybe in the shader. Oh, sorry. It's gonna quit my boy, he needs help turning over it by the looks of it. Alright, welcome back everyone. Yeah, he just decided to try and turn over but he got stuck. As they needed. Right, so the bin index I guess it can just be hard coded for each of these shaders. We'll have to have one for 4, one for bin index 0 for now. Yeah. So if the dispatch index goes outside of bounds for the object count, then we bail. Now those are got these weird little they're kind of wrapped structures actually. So when you say dot whatever, so actually in that tile bin ellipsoids 1, we'll need to quickly just change that and say dot raw because they're wrapped structures so we can get them cached line aligned. Neat. Cool. So right. So yeah, these are really right. So you then need to fish out the object. So there's a base offset as well we've got to use. Each bin is a base. There's one big array where all the bins exist, and each bin has got a max of 64,000 entries, or 64k. So there's a base offset for each of them. So you need to essentially do something like this. That will get you correct. Right, actually, you've got to add that, or maybe you need to do a takeaway. Yeah, because these are initialized to that base offset here. Yeah, good. Yep. Cool. That gets the object out based on the bin. Then it gets the bounds, goes over all the bounds, and inserts in. Right. So we'll copy paste that to each. So 4 times, and we'll manually improve them one by one. So we've got 4, 16, 64, and 256. They're going to get improved later on, not now. That is bin index 3. Um, 2 and 1. The shaders will change completely. Or possibly. So the next thing to do is to actually launch them all according to the dispatch args. So in tile bin start. So this is the one that actually creates the tile bin objects, an array of them, the ones that you want to bin. And this is the splat code, so the splat ones. We need to go for every single bin. Graphics tile bin object bins count. So there's 4 of those. I'll run over. Do some sync code. Now, these ones, you don't want any hard synchronization. They've got to allow to be ran. Where's the read write dependency? Yeah, these have got to be a no overlap. Here and here. And so in the future, this should hopefully allow these to not overlap. So there should be one barrier that gets placed here. And then these should not get a barrier that gets placed after each of these or before each of these. They should be able to overlap and run at the same time, and that will improve performance. So you're not stalling between each. Each different splat shader. So we need to get these each in an array. Splat shaders and then bin index. So that'll be something like ACC shader, splat shaders, and just fill them in. It'll be a 4, 16, 64, and 256. So populate those, kick them off with the dispatch args of bin index. Right. Yes, using an atomic, so you might be able to get away with a no overlap. It's an atomic on here, so it should be fine. Hmm. Maybe. That's my hope, at least, in the future. So, we've got a problem, I think. And that is, I don't think we made it such that these get clamped for the 256 one. So that shader where it's that bin ellipsoids. Yeah, so when it works out this one here, so if it's great, yeah, this has probably got to be clamped between 1. Yeah. So what I should do, a clamp U32 between 1 and 5, probably. 4. Because 4 to the power of 4 is 256, isn't it? So 256, that'll give you 8. And then another one that's 4. Yeah, good. So between 1 and 4. Rightio. So that will clamp it. So all the ones that exceed 256 will be clamped into the 256 one. Right, let's think about that again. So if they've got a, like the number, or I say 6. So we would get the most significant bit, that'll be 3. Then we get the most significant bit again, that'll be 2. Then we take away 1. That'll land me in the bucket for the 8, sorry, the 16 one, isn't it? So yeah, I don't know if we need one which goes higher. So it should be a 1024 one. Maybe need a 5th bucket. Maybe we need a 5th bucket. Because it goes all the way from 64 tiles all the way up to the full screen, which might be bad. We'll see. Let's just get it running. We can tune it. So we just run that. Gonna get some compile errors, but we can fix those. Right, 1024. What a nice line number. Right, .x. Whoopsie. One up. This one's obviously messing it up as well. Rightio. If I'm padding filled, what I've got to regenerate the scripts. Right, I'm going to manually add that field in. The problem is my encoder, that makes code, is dependent on too many things just to get it running. So it includes GPU stuff for no reason. Alright, hopefully it still works. No. The answer is it clearly fails. So let's take out a look. So we are dispatching those 4 splat objects. They are being set up. We have numbers here, which is interesting. They are completely wrong. They're obviously offsets. But 2 do get added to the sort entries count. So it does look like things make it in, but the values might be wrong. So let's sort out those. Is it gonna? So splat setup. Then splat setup. Let's get proper counts. Oh, it's launching way too many. Very problematic. They're not actually counts anymore. They're kind of like base offset. Really, they should be called. Right, I've got to do this manually. They should be called. Well. Like object bin next index. Next indices. Something like that. That'd be the kind of the better name for them. I got to change it in the header file and that's right, it's done. Cool. Alright. So that'll print out the proper number in the terminal now. So we should see 2 in one of the bins. So right, well 2 in this bin here. So that is bin, so 4, 16, 64. So it's the bin 64. We haven't really changed much. So we go into here, right? We ended up getting the number of tiles. And somehow we added 2 in there. Wait, we added 2? Why have we not got 2 in there? It should have far more. But they are a lot bigger than that. So I think some of this information is just maybe not good memory. I don't know. So we could print out a few things, right? We could print out GPU hprintf. So we'll print out 2 objects that we visit. And this would be the sort of like found. So, okay, read. And then we'll do a write as well. So the write would be inside tile bin ellipsoids. We'll generalize this code very soon, hopefully. So this would be the write insert index like that. So let's see if they're actually writing to the same indices in that big old binned objects buffer. All right, let's close that. Scroll up. What we find out is they write to these and then they read from 0 and 1. Seems incredibly correct, doesn't it? Yeah, it does. I thought. Huh. Right, I think I was a complete wally there. Yeah. So I obviously need to add the offset to the. Right, okay. I don't know where my mind was. Right, so we add the offset to this if it goes out of bounds. There we go. An object index, done. So I've got to actually do that for the rest of these ladies and gents up here. Oh, that was not the last one, so there's another one there. Cool. So let's try that out. We should hopefully see some objects now. Oh, I need to delete a line. Let's clean this code up a little bit. Right, so hopefully that should be visuals on the screen. Voila! Right. So now this is where we get to see if it actually works. So what we're going to do is there's a lot of read objects being printed out. This is a bit concerning, not going to lie. So not seeing any there. Not seeing any there. Oh, they're showing up on this one here. Right, but okay, so as they grow, they end up in the other one. Right. Different bins. So they're already being tested on the different bins. That's great. Right. So that's why we're seeing the performance tank. Let's just say that's working okay. We'll reinsert these if there is a clear problem. So let's move around the screen. So if we make them bigger, this should put them in the final shader. Pause it. No. They are not in the final shader at the moment for some reason. They're in this one here, so 64 tiles. They should be in that one. If we take a look at the counts, they're getting a lot of entries. No, the 256 one is running. I don't know why we're not seeing it. It seems like it's got some entries in it. Right, let's put this right one back in. So I want to make it a bit clearer. We'll say in bin this, or the bin index, so we can at least pause it and just check what bin it got put in. But it's rendering. That's the main thing. It would be nice if we printed some of this on the screen so I don't have to pause it. And we could have just printed it on the screen. So these got put into bin 2. a Y. How many tiles is it? Because that determines how many bins. Yeah, maybe. Yeah, maybe it is working as it should be. So let's have a look here. Right, it's definitely wrong. Those ones are in like the thousands. I don't know why it's getting bin 2 though. It's probably the maths to calculate the bins caps out at 2. But it seems like it is running, but that could be the profiler doing its silly thing again. I wonder if we could time barriers. That would be interesting. Could you time barriers? Place a barrier down. Probably not. Yeah, I don't know what's happening with those timestamps. They seem a bit off still. Maybe. Hmm. Because the last shader shouldn't even be running. We saw that the count is 0, meaning it won't get any dispatch. So this is like similar sort of time. Thinking that the timestamp is probably included in the shader before it, even though it shouldn't. Mm. Look into that a bit. We'll do that later. Let's just try and get it working. So that is because this from tiles count is wrong. Times at 4. So when we did like a 256, or it was more than a 256 when it was like 1,000 odd. 1240. Hey there, Mr. Still. Hey, I have a simple macro that does not work. According to the pacemaker, can I take a look? Sure. Sure thing. Extravaganza. Oh yeah, I've used this built-in before. Neat. Yeah, so using those return things. So you've got a print here. Isn't that going to return comes from the print? Because that will get you using the GCC extension for returning a value, right? So that's going to get returned, whatever the result is. But then this, right? Even if you pass a void function, right? It might be doing that. Um, so this is an avoid function, right? So those are not compatible types. So this here, I guess, is a function type. You do something like, what do you put? What you know? Um, so I guess your wrapper needs to take in like a function, right? A function parameter. Like it looks something like that. So a proper like void. You're talking about a void function with a void return. Is that what you're looking for as a return type, or the whole signature itself? So you know even the parameters and things, right? Um, yeah, you can't check for a return type by the looks of it. Only. I don't know how you do that. But yeah, that's not checking just the return type. Yeah, this is not getting the return type either. Or at least it shouldn't do. Right, how does typeof... Does typeof give you the return type and not the actual function type? Hmm. Right, so let's punch that number into the calculator. So it was... Right, 1240. Right. So we did the most significant bit, right? So that's 8, 9, 10. So we give you 10. Then most significant bit, which would be 4. If the else part does not have anything but print, then it will work. Weird. Huh. I'm not sure how that works, not gonna lie. So what is type of function? Is that meant to be... Does it really give you the return type? It does. No, it doesn't. Oh, this is the Microsoft one. I don't know. I don't know if it mentions it. Yeah. Yeah, I'm not sure. Alright, so maybe this formula's wrong. 256. Most significant bit would be 8. No, no, it's still right. Yeah, so that we did this one before, so it'd be 8. And then 4. Then take 1, get you 3. So why are we getting 2 for a... So we did 128, 7, 3. Wait, let's do that one again. 128 is definitely 7, yeah. It's index 7. Then 0, 1, 2. Right. And then take 1. Right, so that'll put you in the 16 bucket, not the 64 bucket. Yeah, that's not good. So that actually needs to be 3 instead, and then you remove the take 1. How are we going to do it though? So I think you're saying up to... You might have to do a +1, you know? That's 3. Okay, so if you got 0 to 4, they're all going to work. Yeah, 0 to 3 and then 4. So 0, 1, 2, right? And 0, 1. So that will go into the first one. Yeah, yeah. So maybe you have to do sort of like a max 1, take... Max 1, take 1 here. That way it sort of goes into the boundary before. That handles up to 4. The next one handles up to... Yeah, so then we did 255. That'll still be 7. Right, 7, 3. Yes, up to... Yeah, that'll still be in the right one. Yeah. That's good, that's good. That's what I was thinking, we might need like a 1024 one to the next level. We'll see. But that should be the right bin index there. Okay. So I guess let's test all these different bin indices and make sure we get the right ones basically. So let's try and... Did we just crash? I think that's a GPU crash. No. Cool. Alright. So I'm going to move backwards, maybe, just maybe. No, we're never going to get them really small, put it that way. It might be possible. Yeah, I think they're okay. I think that code, part of the code's okay. Yeah, so we've got 1 in this bucket here, so that is the 4 to 16 tiles. And 1 in the other one, they both render fine. Yes, one's got 8 tiles, that one puts in bin 1. Yeah, the other one's got 42 tiles. That's from the 16 to 64 category. Right. Very nice. Cool. Yeah, so we just got to go ahead and write more optimized shaders now. So that binning is correct. Or the different binning correctly into different buckets at least. I might want to add another one though for scaling to more. Yeah, I guess let's just finish off the different splat functions. So the fours, you want to do this sort of n times n complexity because you'll be going from 0 to 4 inclusively. So this will only bin, right? Bin or splat object but you'd never have a 0. You would never have a 0, but we maxed it anyway just in case, wasn't it? Yeah. Right, splat object 1 to 4 times. So this shader optimized for splatting object 1 to 4 times, optimized for splatting 5 to 16 times. (17 to 64). So as you can see, there's quite a lot of headroom here. It's 256. Well, actually, this is plus, isn't it? Maybe maybe we'll make another one. I think we'll do 256 plus here. Yeah, we'll do another one. Be fun. So let's do 5. I think that's all we need to change. It would be nice if it was less buckets, put it that way. In terms of memory cost, the 64K times 5, so it's times by 16 bytes each entry, 5 meg. Alright. Cool. Yeah, so that's built for anything above 256. You could probably loop 256 here. I guess we can just optimize this one and just see how we go. The whole idea is you need to write this splatting code differently. So rather than processing one thread for each object you want to splat, instead you need to splat so instead we'll splat this, the same object for every single thread in the dispatch group. So this code is going to be a bit different. I think we'll use the group index instead to represent the object itself. So that would then mean that when we do this the splat objects thing, technically, this doesn't do a divide by 32 anymore. You have to do it manually. Right, time for copy paste, I think. Alright, makes this shader a bit slow, but screw it. Yes, the final one. We'll just patch it afterwards. Oh, no, we won't. So we'll do a quick little hack. I'll do it proper in a bit. Visual Studio. So the way it puts it in there is it just shoves the objects count in there directly. That's how many groups it's launching, is one group per object. Maybe we could change how it works. We'll see. We'll see how it needs to work. See, there's one group per object. Right, CPU side, we need to add another one. Will be 256 plus. Neat. Yeah, so for this 256 plus one, we use the group index instead. So that gets you the object index. Get your object out. Right, that should be an SGPRs. Maybe you can preload it into LDS, I don't know. Anyway. Then the way you do it is you get rid of the loop. You probably pre-put that into LDS, all of that. Get the loop. And you want the first thread within the... Where's the control barrier? You probably still need a loop. Base index. Add by 256. And then you want to figure out, by doing like a wave prefix sum. Am I the first entry or something like this? You would say like thread index, something like that. And we're doing one. Well, probably won't need that there anymore. Did that number right? Yes, that take the offset. Good. So you put your control barrier in. You will need some LDS memory. Let's just call it LDS for now. I just want to get it working. Dispatch group memory, LDS. So this one specifically is going to be, you probably just want to know the number of tiles, and you probably want to store. What do we need to extract? Yeah, so you'd need to figure out like which X, Y are you, and then add some kind of like min, basically. Min X, min Y, and then you probably need the object ID and the depth. Those are the things that you need extracted out into LDS memory. So you put a control barrier down somewhere. So you say if SV dispatch. I think you get away with SV dispatch. That'll be your local index. If that is the first one. Figure out for me all this stuff, and put a control barrier down. Dispatch group memory. So stall all of the waves that are running out of sync and wait till they all at least repopulate the LDS memory with this. Egotist, my friend, thank you so much. 21 months. Oh yeah. Nearly 2 years. Thank you. How have you been? So all we have to do is you extract out the object. You might need a width as well. Like what is the sort of what is your tile grid width? Yeah, and probably some form of like base index as well, base tile index type of thing. Right. Just fill that LDS memory right up. So object is equal to obj.object. Good name. Depth. So the depth of the thing we're trying to sort, to get sorted from front to back. The base tile index, which would be essentially the tile coordinate min dot x or the y multiplied by the grid width plus tile coord min x. Cool. Min x min y. Maybe something like that. And the tile, so we want to specify some kind of like width. And maybe the tiles count. GLDS tiles count. And the I think that is just basically the max. How do we know the height that we span? Yeah, that's in the tiles count. Good, good, good. So it's the max x, take away the tiles coord min x meet. Right, so now that's in LDS. Afterwards we can fetch it all out. Here we're looping, let's say we need to splat like 1,000 this 1,000 times, we loop over this 4 times. So that rather than loop being, you know, 32 by 32 in a 2D loop, it will instead be 1024 in 4 loops. So there's far less loops with inactive lanes going, basically. Although there is a bunch of inactive lanes going here, but yeah. This will be heavily optimized. So now we're just going to work out the correct tile index. So that will be effectively GLDS in this case. Dot. Hope you're having a wonderful day. I've been busy lately at work, unfortunately, but doing well. Awesome. Good to hear you. I've been probably busy too. Just actually quite tired. Probably tell. Yeah, just busy working and looking after the boy, seeing my wife, spending time with my wife, family. But yeah, I went shopping at the weekend. Some more Christmas gifts. I think we're nearly there now. Also, we're hosting Christmas as well, so gonna be very busy. Yeah. I think things just keep getting busier as you get older, and I don't know how I'll be able to get even more busier than I am. But yeah, doing good. Other than that, other than just being super busy. Toast Farmer, welcome. How you doing? Hey. Welcome to stream, sir. Said you've been here before, I guess, but maybe. Tile index. So I think you can use that base tile index, right? No, you can't do that. Because you got to offset by whole rows and things. No. You've still got to figure out. So after every grid width, you've got to figure out. Right, so I think you need to work out. Yeah. Right, so with this sort of like, who put an S32 there? Signed. So we need to turn this into an XY. So we can mod GLDS tile grid width. That will get us the X. So this is the relative X within the range that we're trying to splat, and the relative Y. Nice divide. Now, with this relative X, relative Y, we take the base relative X, sorry, the base X and Y, and use that to compute the real XY. So that would be sort of like GLDS min X plus rel X. And with that, you can compute the full tile index. Oh yeah. Then you jam the width in there. Sorry, the depth in there. Close enough. And the object. And you got to get the insert index right though. The insert index is going to be base index plus local index, right? The prefix sum, basically. You got to be careful though. You should only do this if this insert index is less than tile count. So what we're trying to beat is 1 millisecond displaying a full screen worth of objects. So this should hopefully bring it right down. I'll be able to find out. Awesome. Yeah, basically no libraries. I use libraries, right? Typically single header libraries. I don't have it Yeah, I only use single header libraries or system libraries. These are the way. Right, so which one of these silly things I don't use? Yeah, it's good fun. And also increases my sanity because I'm not dealing with basically crappy code and crappy build system stuff. Um, you know, the operating system code isn't the best. And you have to interface with that, but you just build it once and then you typically don't have to touch it. Um, again. What are ways if the game engine's UI? So I've got my own UI thing, UI.h. It's a custom immediate mode UI written in C. Yeah, it's alright, does the job. It is kind of like ImGUI, where it does it in a single pass. It's not a multi-pass immediate mode GUI, but yeah, um, pretty good. I like it. Things could be better, but got a lot of things: combo boxes, split areas, scroll areas, color pickers, um, some weird SDF-based drawing API, which is just bananas. Um, yeah, what I use the UI. Um, yeah, I work as a graphics programmer, graphics engine programmer. Originally, I was hired as an engine programmer. That was the job title, and then this my boss. It was just two of us. Was the guy who did all the graphics. Um, the team got specialized into graphics, so then I got into graphics. I was already trying to learn Vulkan on the side anyway, and stuff like that. So I got kind of, you know, it was good. I like it. Um, I kind of fell into that area, which is great. You know, rather than falling into web development, which I did before. You know, web development was like the only jobs around here, so I was like, let's fall into doing web development now. So, kind of got the opposite experience, which is great. Got to do some, get to do some graphics programming, which is really fun. Um, you know, because typically people don't try and oop the crap out of it. Yeah, exactly. You know, it's fun at the start, right? Because you don't know anything, but when you really want to like figure out how to do stuff low level, you're like, I mean, you learn that you're really far away from the machine and all this, blah 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 blah. You know, it's a bit depressing for me at least because I like understanding the how things work and stuff like that. How long I've been doing engine and graphics work? So engine work. I started doing engine work similar time to when I started doing. So I started learning JavaScript, and then I started trying to learn C because I wanted to learn more about the low levels, but also learn how to write games. Um, but probably C++ actually. It was probably C++. And then I got really confused with pointers, and I basically was like, all right, I'm not, you know, I'm gonna just stay in JavaScript. It's the easiest, you know. C++ is too hard for me. Then I tried it again a few weeks later and got into that. So that was about probably started working about 14 years ago, or started programming about 14 years ago. Then about 2 years later, I tried tried to switch over to C++ and that. And from then it was, I heard about SDL2 and stuff like that. So I would try and write my own engines and stuff and games. I write like small little prototypes and things that get thrown away, and try all sorts of things. I write in texture packers and all sorts. So it's been like a good 12 years probably now. Um, and then graphics is, I've done OpenGL for a while, but seriously doing graphics work was since I started learning Vulkan, really. And so probably looking at about 4 or 5 years. Um, actually doing 3D, not just doing 2D. I want to start on my own IEC 61131-2 compatible language compiler runtime for some microcontroller 5 mega skill issue. Right. What is IEC 61131-2? What is that? Right, let's just double check this thing all makes sense. Right, base tile index is not needed. Right, this sort of grid width thing, it's like how many tiles does this thing span across the x axis, basically, But it's different from the one which is in the. So I guess you can call this object tile grid width. Right. That's the insert base index. Don't be a wally. So go across the x, recompute the xy, then recompute the overall tile index. Bam. Neat. I think that'll work. Let's give it a go, see what happens. Worst case, it just crashes. And it doesn't bring down the whole desktop anymore. Somebody did a silly, that was me. Like ladder logic for in PLCs. Well, I'm not sure what that means. But yeah, sounds pretty cool, low level though. But yeah, just do some research and get in there. Best thing you can do. Um, hands-on experience is probably the best kind of experience. Reading stuff and doing hands-on at the same time, I find is the best way to learn. If you just read a whole bunch, you won't understand it. If you just try and do a whole bunch, you won't get anywhere. So you need some kind of like in between of that. Crap, I pressed F1, so Microsoft's trying to figure out how to help me, which they never can. Yeah, 12 years is a lot, but you got to program your whole career. It's tiles count. Hey there, Cake is messing up your commit. Damn it, your code. What code? Not messy. What are you talking about? Clean code. Can't you see? Crap. Clean code, mate. Rightio. So hopefully this one should run. Right. It's the terminal messes up. It's this sometimes. It like pauses the application and yeah. Although I think it's the terminal. I like to blame Microsoft. Good idea. Right, so we get really close to the. Oh, that you see that speed increase and maybe go forward quicker. Right, let's see how it goes. So if I was to pause. Eh. Right, so how many we got? They're in the 3 shader only. They're not reaching the 3. The 4. Yeah, the 4 one, which is the 256 plus, where we did the optimizations. Well, but they should, right? They're definitely greater than 256. So I don't see why that is. What did I do? Hang on a minute. Right, let's take a big number and run some numbers. So the big number was, let's say 1024. 8, 9, 10. So that's, we get the most significant bit index. So that's the 10th one, 10. Ooh. Yeah, that's fine. No, it isn't. I think so. No, I think it's fine. Then we get the most significant in 0, 1, 2, 3. So it falls back to the 256 one. Hmm. So if I did 256, that's 8, right? There's the 8th one, so 8 in there. And then we do 0, 1, 2, 3. Most significant bit, 3. Yes, that's the one we land in. In order to get the one up from that, you need to be... Yeah, that is 1024 in it. Right, so clearly our logic is wrong. You can't most significant bit twice, it doesn't do it. Right, how do you get a log 4? Logarithm. I think it's wrong. Yeah, we don't want that. Do it that way. I wonder if there's a really quick way. I thought you could do it with base 4 because it is a... Right, let's write out the numbers. Because it all overlaps with powers of 2. So powers of 2 are 4, 8, 16, 32, 64, 128, 256, 512, 1024. So the base, so in powers of 2, so this is the number, this is powers of 2, and then this is powers of 4. So this would be, wait, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So we can get the power of 2 really easy with the getting the most significant bit that's set, and it's done. So for this, for powers of 4, this would be 0. This will still be 0. It's not. It's kind of non-existent. This would be 1, non-existent. 2, non-existent. 3, non-existent. 4, non-existent. 5. So how do we work that out? Given the input number n. Yeah, I was thinking I did divide it by 2, but then it didn't work. Maybe I thought about it wrong. Or is it a divide by 2? That's where my first instinct went, but then I changed it. Right, so let's pick a number like 384, you know, a good number. So if we do the trick right, get most significant bit index, that is 8. Right? 0, 1, 2, 3, 4. Right, add another 4. 8. So you put 8 down and then divide by 2, right? So that was 384. So that'll get you. Right, that seems correct. Right. Pick another one. I don't know why I changed that then. Maybe something else I was doing. Right, let's try it again. So we try. Let's try 768. So that is 8, 9. So 9. Divide by 2. 4. That's right. That'll get you. Yep. So we land on. Well, that'd be 256 plus, wouldn't it? Yeah, that's fine. Yep. Or maybe that's it. Maybe that's alright. So we did like. So that's 10. 10 divided by 2 would be 5. Yeah, that is right. I don't know why I convinced myself it was wrong. Let's try like 17. Or even 16 is enough. That would be 4. Yeah. I don't know what happened earlier where I convinced myself that was not the way to do it. I was probably off by 1 in the calculations and it was. Yeah, anyway. So that should trigger the right shader now. Our new optimized shader, which is hopefully optimized. Find out. It's got to be 1 whole second. No, 1 millisecond. Alright. It already fails to do the correct binning. These already writing into the biggest one. Yeah. So the new shader that we've written, the one that writes the most, is failing real hard. It's clearly not writing all of them out. What's going on? Yeah, so I probably just got this thread logic really wrong. So we're launching one group per object. That's the logic. One group per object. Both objects are showing. It was selecting the right objects, that's for sure, but maybe not for every single thread. No, it would have. That's good. Oh, this should be a 4. Right. That bin index was the wrong one. I didn't change that. The constant. So it's the 4th bin. Somehow it was still rendering the right ones, which was very bizarre. Right, but right, still get the same bug though. Bizarre. So if you're the first thread within the thread group, get the object, get the min max out, run to LDS, these things. What is that? Well, somebody right. I found a problem. We're writing over the same insert index into the tile. So this needs to be the base insert index. And this be what's known as the relative index, relative insert index. And then the full insert index is GLDS base plus relative. So the base is this one here. Yes, there's only one atomic add per object there, so we shouldn't get a bunch of threads. Well, yeah, have to synchronize. I don't know. Maybe not. It's all in the same compute unit. Right, that seems to be looking alright. Get a bit closer. So what's happening there is we had each object was writing into the same sort. Was writing this into the same index basically in the sort array. So we are getting a graphical glitch, though I did see it is appearing, so something a bit fishy going on. But nevertheless, still look at performance. So is it a whole millisecond? That's what we're gonna beat. Seems like we're way faster. Let's have a look at this one. Great. That 256 plus one, splat objects 256 plus, is 0.16 milliseconds. And originally, when it was this sort of size, we was looking at 1 millisecond to splat a single object because it's using a single thread to splat 20,000, or maybe about 10,000 tiles. So basically copy the same object 10,000 times. Now it copies it 10,000 times but super quickly because it splats the same object across multiple threads. And there's less inactive lanes. Rather than splitting this one object across each thread, each going over 10,000 iterations or something dumb like this, with a bunch of inactive lanes happening all over the place. So that is definitely a big improvement. That is about it's over 10 times quicker. It's nearing 100 times quicker, but somewhere in between there. But yeah, that's the speed improvement we was looking for. We've still got to make the other split object shaders work. They might be basically the same as the one we've just made, but for smaller quantities of items, the loop iteration will just be smaller. So rather than doing 256 at a time, we might be doing less. And we'll see. We might have to write another specialized one, but the core concept will stay the same with splitting the object. So remember, we're just splitting into these sort key things. The object stays the same, but the keys has the tile index in the high bits and the depth in the low bits. So when we sort the whole array, they all become sorted by tile, then depth, which is what we need for the tile. Which is what we need for the ray tracer, because it needs to ray trace a linear set of ellipsoids from front to back, and that solves the problem. Neat. Cool. So I was hoping to get a bit further today by having it all actually done, but you know, it's more complicated than I hoped, and also there was the was investigating into why these performance times weren't correct, and they're still a little bit incorrect. I think they still include the previous dispatches times sometimes. So it's very hard to know the exact times. I still need to play about with that. Maybe I get some time during my lunch tomorrow and have a look, because it's not great having that problem. Yeah. Hmm. Maybe I can print out the start times and end times and debug it that way. See how they're close to overlapping and stuff like that. It's very weird. Right. So our next Beyond on Thursday, guys, at I don't know, 4 hours ago, Thursday, and probably about 3.5. I don't know, 3 hours Thursday, 3 hours ago on Thursday, and about 4 hours ago on Sunday. There is a schedule on Twitch. You can find it all out there. There's a YouTube VOD channel if you're interested in previous VODs, and there's a Discord if you're going to come and hang out in the meantime. Thank you for everyone who's supporting the channel via subscriptions, Ko-Fi or via Twitch. Appreciate you guys very much. Let's find someone to raid. This guy's doing some open source stuff. I am following people though. There's Artie. Great Artie. We've accomplished speed up 10 to 100 times better. Somewhere in between there. But we've still got more shaders to write, but we're getting close. And get some cleanup as well. But yeah. Success. Right, have a good night, guys. I'll see you all on Thursday, hopefully. Bye-bye.